My name is Narlin Baldos from BSIT 1D. So today, I'm going to talk about fundamental counting principle. So what is the fundamental counting principle? Relationship between the number of possible outcomes and the number of decisions. If we have a k decision to make while there are number of possible outcomes, 1 that the first decision, number of possible outcomes 2 that is the second decision, the number of possible outcomes that is third decision, and n sub k that is kth decision. We multiply first decision times the second decision, third decision, and then so on. How those a tree diagram related to the fundamental counting principle. A tree diagram is a diagram used to show the total number of possible outcomes in a probability experiment. The fundamental counting principle uses a multiplication of the number of ways each event in experiment can occur to find the number of possible outcomes in a simple space. Example number 1. A pizza can be ordered with 3 choices of size: small, medium, or large. 4 choices of crust: thin, thick, crispy, or regular. And 6 choices of toppings: ground beef, sausage, pepperoni, bacon, mushroom, and onions. How many different one-toppings pizza that can be ordered? So the sizes, we have 3 options. We have small, medium, or large. And crust, we have 4: thin, thick, crispy, or regular. And toppings, we have 6: ground beef, sausage, pepperoni, bacon, mushroom, and onions. Now, you take a 3, 4, and 6 and multiply them together. And by doing that, you get a different one-toppings pizza that can be ordered. So, multiply 3 times 6 times 4 is equal to 72. So, 72 different one-toppings pizza can be ordered. Sample number 2. You flip a coin and spin the spinner. How many outcomes are possible? Flipping a coin, how many outcomes do you have? Do you have 2? It is head and tails. And then how many outcomes you have for spinning the spinner? So count: 1, 2, 3, 4, 5. So 5 different outcomes. So how many total possible outcomes? So do you have 2? It is head and tails. And then do you have 5? So 2 times 5 is equal to 10. So 10 possible outcomes. The first event, what are the outcomes for the first event? So we have head and tails. How many outcomes arrive for the next event? Event 5. So I draw 5 separate branches and let's list them out. So I have 1, 2, 3, 4, 5 for head. And then tails, we have 5. 1, 2, 3, 4, 5. So, and let's them out. I have 8, 4, 5, 6, 7. 8, 4, 5, 6, 7. Then list them out. So, H hyphen H, H hyphen 8, 8 hyphen 4, H hyphen 5, H hyphen 6, H hyphen 7, 3 hyphen 8, 3 hyphen 4, 3 hyphen 5, 3 hyphen 6, 3 hyphen 7. And those will be outcomes, and if you can see, there are 10 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 possible outcomes. Number 3. You take a survey with 5 yes or no answer. How different ways you complete the survey? So we're 5 stage. So we have 5 stage. We have question 1, you have 2 option, and question 2, we have 2 option, question 3, another 2, and 4. And the same things, so if I multiply n, 2 times 2 times 2 times 2 times 2 is equal to 32. So, other words, 2 times 2 to the power 5 end up with 32 different ways in which this survey can filled out. So, 32 ways you complete the survey. Example number 4. A company puts a code on each different product they sell. The code is made up to 3 numbers and 2 letters. How many different codes are possible? For first days, let's say we encounter a number, there are 10 possible numbers 0 through 9. So 10 times, let's say we encounter another number 0 through 9, that's a total 10. And then when encounter a letter, it doesn't matter, you can continue with another number. It's not going, but it is you encounter a letter, you have from A to Z, and that 26 possibilities. And another letter would be 26, and another numbers that last would be 10. So 10 times 10 times 26 times 26 times 10 is equal to 176,000. Example number 5. Your favorite fast food lunch as student combo will consist of an unlimited rice meal, soup, dessert, and drinks for 50 pesos, offering the following choices: meal, dessert, and drinks. How many combos are there? For the rice meal, we have tocino, tapa, longganisa, hotdog, and bacon. So we have 5 choices. The dessert, we have yema, polvoron. So we have 2 choices. Well, the drink, cola, iced tea, root beer. So that is 3 choices. How many combos are there? So let us multiply. 5 times 2 is 10. 10 times 3 is 30. So 30 possible outcomes. 6. A factory make shirt and the 5 colors, 4 design, and 3 sizes. How many different shirts can be? Step 1. There are 3 events, namely the color, design, and size. Step 2. There are 5 options for the colors, 4 for design, and 3 for size. And so, how many different shirts can be made? Let us multiply. 5 times 4 times 3 is equal to 60. So, 60 different shirts. Example number 7. A factory makes school jacket in 4 different colors. Each jacket is available in 5 fabric, 3 kind of colors, and a choice of button or zipper. If the jacket are also available with or without the school name, how many different types of jacket does the manufacturer make? So, 4 different colors, and we have 3 fabric and 3 color, and 2 bottom or zipper, and we have 2 options with name and without name. So, how many different type of jacket? So, let us multiply. So, 4 times 5 times 3 times 2 times 2 is equal to 240. So, 240 different types of jacket. Why it is important to know the fundamental counting principle? Using the fundamental counting principle will allow you to find the number of unique ways that a combination of events can occur by simply multiplying the number of options for each event. How is fundamental counting principle used in a real life? This principle states that the total number of outcomes of two or more independent events is the product of number of outcomes of each individual event. For example, a child choosing among 6 flavors of ice cream with 3 varieties of code will have 6 times 3 is equal to 18. So, 18 different of ice cream. And that's all. Once again, my name is Noreen Baldos from BSIT 1D. Thank you and God bless.